Welcome back to the Black Box Podcast. Today, we're exploring how real-world yield meets real privacy. I'm with Paul Mierlo of Spout Finance, where investment-grade corporate bonds, including LQD-grade exposure, are mirrored on Ethereum as permissioned ERC 3643 securities backed by on-chain identities. In this conversation, we cover the full pipeline, identity verification and eligibility, minting permission tokens, encrypted orders, trusted execution environments, Intel TDX as coprocessors for confidential settlement, and selective disclosure when compliance requires it. We discuss why corporate bonds were first, how proof of reserve and audits map to chain, and how CeFi liquidity can meet DeFi programmability without leaking balances or order flow. If you're building private rails for RWAs, or just curious how zero trust finance actually works, this is a detailed look at the architecture and the choices behind it. Now, Paul Mierlo.
Awesome.
So, yeah, 1, 2, 3, and hello. So let me just make sure that I get this straight. So your last name is Mierlo or Merlo? How do I pronounce it?
Mierlo.
Mierlo?
It's actually Paul van Mierlo.
Okay, that's
It's
good
a
to know.
Dutch name, very Dutch.
Yeah, I accidentally misspelt it the first time when I was drafting out our interview today. So, my
Oh no,
bad
but
on
it's
that.
actually it's there. It's correct there. Like, thank you, Paul Mierlo. But there needs to be a fan.
Maybe.
But that's okay.
Okay, so I wanna jump into this, right? So, I think let me just explain how I start to do these podcasts because you're the first ever person that I've ever had onto this podcast, so I'd like to kind of explore what people think this might be. And
Yeah.
so, I want to introduce it really quick. So, the Black Box podcast is where we strip down complex technologies to the parts of the like bits and pieces of it as well. And we get builders on and we basically ask the simple, curious questions to clear up the technical views of tomorrow's systems because we're focusing on privacy centric real world assets now. But most people don't even know what privacy is and the technology that goes behind a lot of the choices that make privacy technology. So today I have Paul Mierlo, and he wants to bring his words of advice. He's the co-founder of Spout Finance, serial hackathon winner, relentless privacy. I almost said that wrong. No, he's never stolen anything. So, but Paul's resume spans the first place finishes at like Chainlink hackathons and like ETH Global hackathons. And then, he's done a bunch of TEE secured transfer protocols too in his stuff. And he did some of the first encrypted oracles. He's put standards out there for like open toolkits for RWAs now, which I think is just a super complex topic. It's not a whole lot of people understand the regularities behind it. And, you come in with a wealth of knowledge, and I'm just super curious about the industry of RWAs. And like, I remember us having conversations about TEE, about coprocessing, about some of the anonymities, but then also you have your own experience in zero knowledge and building with a bunch of tools, and you've been all over the ecosystem. So I want to ask you the very first question. So, what are 3 words that define your mission? Because that'll set the context for where I can start with this.
Yeah. So 3 words. I would say scalability is one of them. Privacy and outreach, I would say. So these are three words I can also describe for the product that we've built with Spout Finance. So the whole case that we are working on is that all the tokenization that happens on the Ethereum virtual machine is by default it's public, which is a problem if you're going to build on the chain that has the most TVL in all of the blockchain networks. With Spout, we kind of wanted to tackle this in a variety of ways. So we have technologies like FHE that are coming into the industry in the near future. that we would want to pivot to eventually if that's going to work. But right now we are focused on TE-based solutions. And we want to do this because it's very important for institutions to have privacy when transacting on a public network, and you still want to have all the interoperability advantages, but also want to be private, right? So imagine you have your off-chain bank account or investment account, and you're making a transaction.
Yeah, like I have $2.4 billion in total reserve, right? So I have a bank account. And then, so let's talk about the bank account really quick, right? So like, what is a reserve in this case? So can you explain to me, I guess, can this be any account, or what kinds of accounts are these? Because I think the development behind how Spout Finance sort of, I guess, lists these specific accounts, is there any kind of specific listing that you have to do?
So for Spout Finance, how we do the accounts is we for a tokenization process, we aggregate all the users' funds into one account. So this is deliberately done because you don't want to have like individual management of accounts per user, but you want to aggregate all of those to get a very easy estimate of how many funds are in our bank account that represent the actual bond that we're holding and the amount of tokens we can mint. So this is also a very simplistic way, more simplistic to actually build out this architecture as well, because otherwise we would have a separate account per user, and that would also differ a lot in the legal entity, how we need to structure that, which I believe right now we are a transfer agent, or we can file as one. And that would make the customer acquisition strategy also much easier. So we don't necessarily only have to go for institutions. We can also go for people that want to do a more simpler KYC check. So like a passport identification or anything like that, which would be beneficial for accessibility of these funds as well. So right now I'm talking about LQD, of course.
Interesting. So yeah, so you mentioned LQD. What does LQD stand for? If you can explain that to me.
So LQD is like the BlackRock issued corporate bonds ETF. So right now we are only doing ETFs, which makes it much easier to manage that. So we are not the manager of the funds that's already managed by a primary issuer, and we are just making these investment vehicles usable on a blockchain network. So the eventual goal of that is, okay, you buy into this ETF and you can use these tokens.
Yeah, they have a total return with a market price, with a benchmark. They are pre-liquid, they're tax post-liquid. So they have a 1, 3, 5, 10-year script. It's a long-term yield strategy, I see. So is that it? Is it a yield?
Exactly.
That's interesting. So now you're entering into the field of DeFi. So well, that's a ball game for sure. I think like who came up with this strategy, I guess? Like how did you find this out?
So for issuing safe collateral, because the whole edge case we had here is that we want to have a tokenized product, but that's also a good collateral asset. So that's also in terms of usability much better if you want to scale this product. So a lot of people want to think about like stocks, things like that, right? And stocks are very obvious, but they're very speculative. And in our thesis, we work with collateral that has the following characteristics. So it needs to be highly liquid, it needs to be a predictable yield, and highly liquid, predictable yield, and high liquidity. So
just so I got that straight, so it takes 3 parts. It's highly liquid, highly predictable. How does
a predictable yield. Okay. So with the predictable yield, I'm more saying that it's the yield that you generate from the interest that you get is very predictable. Which is very, very, very useful for if you want to issue a good collateral product. So those are the things that we work with.
And so that LQD, right? So
Yeah.
uh, I was originally thinking that we could break that down a little bit further, but I think we can break down the whole sort of other sort of bond and the entire industry of yield as a totally separate episode. But like, I want to make sure that we come down to like sort of the bare minimum choices that you had to make, because this is it's obviously like a proof of reserve, and it sounds like that there is a type of share where there's a one-to-one with the reserved asset, and so
Yeah.
you're doing something where there's a privacy preservation, and that preservation is over ERC 3643.
Yeah.
So ERC 3643, so like, let's talk about the utility of that.
Yeah.
Does this standard provide, I guess, for this one-to-one proof of reserve? If you want
Yeah.
to.
So so we have two parts here, right? So you have the privacy part, and you also have the ERC 3643 standard. The ERC 3643 standard is not necessarily built for privacy. It's more a standard for permission token issuance. So the ERC 3643 also has a additional ERC implementation that's called ERC 725, which are decentralized identities. And these decentralized identities are more used for verified issuance. So, for example, we have a customer that we need to verify first in order to give him the tokens, which he buys from us. So this is all public data. This is still being done on top of the EVM. And these ERC 3643 token contracts inherit from the ERC20 contract as well. So you are completely interoperable with most DeFi protocols while staying, completely permissioned, and you have all the necessary KYC verifications in place.
So institutions can they can remain compliant. Is that it? Is so that you can have immutable records of all of the data that you're going to need and require from I guess what the bond really needs to be. I guess what are a few of those requirements that they require the most?
Yeah, so you have a very basic ones, right? So KYC requirements. So how the ERC 725 work, in order to be eligible to claim the tokens, we need to issue a variety of claims on the user. So there can be a KYC check, it can be an AML check, or any other additional checks that we need to do in order to give out like a safe issuance for this. All this actual data is being stored off-chain. So you are first doing the verification off-chain. You need to make sure that's all audited, right? So you can't just do that out of the blue, but you need to make sure that's audited. And if it's audited, then you exercise a check on that, which we can do by signing a message from our trusted issuer. And this trusted issuer is like our own externally owned account, or it can be a multi-sig wallet. The bottom line is that it needs to sign it. So with that claim signature, we can exercise that verification check, and then he is eligible to actually mint that token.
Yeah. So it's the root certificate. Yeah, exactly. You that was a great way of explaining it, by the way. So thank you for that that whole breakdown, because I just think, in terms of the root certificate, you're talking about the trustee, the auditor themselves, but it's also okay.
This is interesting because this is not really the root certificate, I would say, because this is like in a sense of like SSL certificates on a website. But this is more like, okay, you have a smart contract, and that tracks who can actually exercise claims. So you as a user also have your own identity contract, and you can only add claims to your own identity contract. But in order to be eligible to mint our tokens, you need a claim that has the exact signature from our own identity contract that has a wallet that can execute or exercise transactions on that. So how that works is we have an externally owned account, can be any Ethereum wallet, and you want to sign a piece of data. You exercise that signature over it, and then that signature will be stored in the identity contract of the user. So that user then has the claim to actually say, okay, I'm verified for XYZ. It can be the KYC, AML, or any other checks. And then he can mint or burn the tokens. So, yeah.
The token in this case is a identity as well. So what I'm wondering is that now that you have this system, in shape, where like it came from like a long chain of of a lot of different pieces coming together. So the way that I understood it is that there was a lot of institutional desks that would just generally collect yield based on their interest. And so you're kind of moving a lot of size in the scale of that interest, but you're broadcasting the actual order flow with an on-chain identifier. So you're sort of meeting all of the compliance rails because you're trying to execute this in a confidential way. So are you so yeah, tell me about the confidentiality sort of like guarantees that are I would say like the most important in your design.
Yeah, so there are some of the design choices we are making that really gives more trust to both institutions and regular customers. I would say regular consumers, which are encrypted order processing and just the regular transfers. So with encrypted order processing, I don't think you can actually look that up and see what it looks like, because this is a term also what I self thought of would make sense. But oh wait, it's kind of like it.
Is
If
that
I
it?
read it, okay.
Let me
During the
see.
order
I
of
don't know what it means yet. Actually, I'm still trying to learn. So yeah. Okay. So encrypted order processing refers to the practice of securing sensitive order information. Right. Okay. So like payment details and personal data. Right. Right. Okay. Now
yeah,
I'm
that's it.
following. So during the order
Yeah,
fulfillment process through encryption techniques. Okay. So yeah, so the encryption that you're running through some kind of input, you're needing it to be absolutely protected. You don't want to put it in a database. You don't want to be encrypting over a database necessarily, it
well,
seems. It sounds
yes,
like you're trying to do this in a more linear way where there's more of like a less centralized sort of database scheme. You're going for more of like an edge, like a
yeah,
co-processing type of approach with contracts, which makes sense because you can always derive the root key from a decentralized node. So like we have a democratized stack, which is less of a one key comes from one place. It's that the blockchain issues the key ID. So there are more private keys that can be used in confidential containers now. So like that's been like a huge new thing thanks to like Intel TDX and the types of root certificates that you were talking about before, which I think was sort of about the SSL versus the root certificate use case. So like the co-processing that you're doing that needs to be secured within these sort of an enclave. The co-processing you're trying to do is effectively called encrypted order processing. And, during the fulfillment process, you're trying to encrypt in a fashion that is also both on chain using zero trust arguments, which I think is like very difficult to do. And not a whole lot of people come to this sort of idea. Does this make sense? Because I'm just trying to
yeah.
explain
It
what
makes
I'm seeing.
it
But yes.
it makes a lot of sense because okay,
Okay.
so you have two parts here, right? The database part and you have the on-chain part. So we have both. So you first, for the database to actually read from the actual state, we need to have all these events that are emitted on-chain. So for example, we want to keep our product as much as verifiable as possible. So with that, we need to bring all this information on chain to have maximized trust in how it's done. So for example, you place an order for a certain stock purchase or a bond in our case, you have all this information on chain and that's all encrypted. So you can selectively decrypt this information. And this is done through the Inco Lightning library that we're using right now. So we have a decryption key that's up to the user that he can implement in the smart contract to selectively disclose this information. So let's say you want to encrypt this information on a smart contract, and then we have a decryption key in our database, in our backend. So we can read from the event still on chain, and then we can decrypt that information on our database. Yeah, this is Inco. It's a great company, by the way. So I worked with this technology stack previous with a good buddy of mine, and we built like an MEV protection DEX solution in the hackathon with this.
Oh,
and
nice.
we loved the technology so much that we thought like, okay, this is something that would be great to implement with RWAs, because RWAs benefit so much from privacy in itself. But there are so many like privacy focused chains that we do not want to dive into, right? So I think I have a very like conservative stance on how confidentiality should be implemented, and that should be on the most decentralized network that we have, which is Ethereum. And there are like other solutions that we also looked into, like Provable, like Alio, right? You also have a lot of experience with that, and some other chains as well, and which are great solutions in itself. But most of the DVL is still in EVM, and a lot of people benefit from having that shared security from a decentralization with the confidentiality in one part, which greatly benefit the whole network and the product itself. So there's so there's so much.
Yeah, no, let me
gain
interrupt
there.
you really quick. So I understood a lot of what you were saying, but now
Yeah.
what I'd like to understand a little bit deeper is like you're finding interest in like using like confidential systems in general, but I think what's
Yeah.
really interesting is like the design the design patterns that you are discovering. So let me just bring it back really quick because
Yeah.
I just want to make sure that we stay on the same front. So it it sounds like this naturally comes to you. So it sounds like something is coming naturally to you. I'd like to understand more what that is actually. So what would you say actually is coming natural to you in this entire equation for you? What is shaping out Spout exactly?
Yeah. So what comes natural to me is that we have a big lack of. So we do have transparency in blockchain right now. That's like the most common like use case for blockchain, but we don't have selective disclosure. And selective disclosure is extremely important for products like RWAs, but also stablecoins, right? So there are two parts of the equation there: stablecoins and RWAs, which are gonna probably be used interchangeably. Because if you look at it, this can be implemented as a stable coin in some way if there's a lot of liquidity for that and there's arbitrage happening. So it can be backed by that. Exactly how we're gonna like do that, that's gonna be up to discussion in the upcoming months. But right now it's just gonna be an asset backed token up to equal to the LQD corporate bond. But
Nice.
yeah, privacy does come naturally to me, and this is something that's being solved by certain parties, right? So we have Zama that's coming with the FHE, which I think it's a awesome solution, because fully homomorphic encryption really ensures that there is a maximum confidentiality in all transfers, and TEs are great. It are the best solution right now if you look at ZK versus FHE versus TEs in terms of like the scalability part. So TEs are really the best solution there. So that's also why we couldn't, why we didn't hesitate to try it out. And I did look at the Zama integration part for like FHE, which is also, if I'm not mistaken, going to be launched on Base.
I'm unsure. No,
So right,
I don't know actually. But why focus on like the corporate bond space then? It sounds like, you know, like
yeah,
that is a separate, entirely separate industry. You're talking about a lot of the toolkits. So when you say like Zama, they're like an FHE system. And then you have other systems that are involved like Inco. So as far as like the RWA, right, part, or at least the
Yeah.
programmability of these systems that need to be guaranteed, like encrypting memory or any kind of encryption or decryption, how do you decentralize that process? Because I'm discovering even like things like DStack, and there are other systems like Fala which provide that decentralized root access. Then unless if it's coming from a central key store, then that means the key store is being managed by some kind of administrator. And I think
Yeah.
in terms of like the types of trusts that you're kind of going for,
Yeah.
is that you would want this not to be changed effectively. Like once it's live, once the bond is live, then I guess the type of guarantee that you're essentially issuing is that this thing is not going to turn off, right? Like, I mean,
Yeah.
once we actually go live with this bond, we also want to make sure that like it doesn't just get removed from memory or in the global World Wide Web. What, like, have you guys thought this far about it? Like, what's the key
So
here as far as resistance to the actual bonds themselves, the yields themselves?
yeah, so there are two parts here, right? So we have a centralized issuer. So it's not only decentralized. We are just issuing this on a decentralized network because that's also where the most TVL is for Ethereum. Then in this case, and we also want to solve a lot of like the very important parts of the EVM, like confidentiality, and we want to make this token completely interoperable with existing DeFi solutions. So think about lending protocols like Aave
Mm-hmm.
or anything, where we want to have like safe, good collateral. Because earlier I was talking about the characteristics that makes up good collateral, and I forgot one thing. So it's high liquidity, it's a predictable yield, and a stable value of the token. And that stable value is very important because we have a lot of over collateralized positions in the market, like Bitcoin, Ethereum. And although I do believe in some of them. I don't believe in Bitcoin as over collateralized. It's obviously over collateralized for lending, but I don't believe in the whole utility of Bitcoin. But if we look at Ethereum, for example, which is a much more interesting case for me, we still need to be very over collateralized because we don't
Wow.
know what the market is going to do in the next month. It can be down 50%. So that health factor that you get in Aave, like the liquidation risk is going to be high. So if the
Wow.
liquidation risk is going to be high, you tend to need to have much more collateral.
Mm-hmm.
And so with corporate bonds, the liquidation risk is going to be much lower, right?
Mm.
So for the bond itself, it's safe. It's an ETF. It's managed by BlackRock. It's not managed by us. But we guarantee that centralized issuer that we are a broker dealer, or we are not a broker dealer, but we have a party that we partner with, that is the broker dealer, and that makes sure that these bonds are actually safeguarded. They are actually bought by the clearinghouse, and they're actually stored.
Mm-hmm.
So there is definitely a level of trust there
Mm-hmm.
that we are. That will be our mission to enforce that every day, to get that trust to the user that we're actually holding those assets for the user.
Mm.
And
That's good.
so
That's good to know
yeah.
because I think that having that sort of trusted issuance is very hard in business practices. And so yeah, like I think if I were to launch a program today, but then,
Yeah.
you know, as far as how it was autonomously managed, you know, this is where I want to get into the idea of the types of, you know, ways or methods that you're using even AI to manage any of this because I mean, we went from decentralized autonomous governance systems, and so you know, would you kind of classify this as like sort of a CeFi to DeFi sort of play? So it's a little bit of both. Is it a
Yeah.
traditional play on finance, but in a decentralized manner exactly? Like because the contracts are there, right? That's what I want to point out is that the contracts are the decentralized aspect. The TEE can also be a decentralized issuing. Like you can
Yeah.
issue contracts through a TEE, and I think that also can be private data. Um, you know, I think let's demystify that for a second. Like just because it's a TEE does not necessarily mean that it's doing anything that's in a central manner. It just means that the reasons why it's executing it are actually in endorsements, basically. So
Yeah.
you can create light clients with TEEs. You can create all sorts of different, clearinghouse clergies or any kind of consortium, DAO mechanics. These are just scripts that basically are application containers that allow you to execute confidential system memory and even issue private keys because they're safe. They're safe to be computed in confidential co-processing units. So I think that's like really exciting that some people are going to start taking advantage of the edge. That's what they say in like Web 2. Mainly, it's like it's the edge co-processing system. It's able to do things like in Netflix. It's able to kind of, sprout not I almost called your company Sprout a few times, but it's like it allows it to
Yeah.
grow and yield. So Spout wants to do something like a zero trust inability that a
Yeah.
lot of people, companies just don't have this ability because they don't have these sorts of guarantees. And I think that really sets you apart. And at Fala we also think about this as well, and I do shout out to Fala because this has been a key focus that's very hard to get correct unless you understand all of the verifications that go into what it means to attest to something that is truly zero trust. Zero trust means
Yeah.
that there is still a trusted party that learns no information about the information itself, just the attestations. And so there is a level beyond verifiability in DeFi, and it's a huge reason why I think a lot of developers are sort of like aggregating over to it because now it's more widely accessible to the web. And so you're going to have a lot of partners within this system. Are you going to use like the Chainlink sort of ability? I know you worked with Chainlink on oracles. Are
Yeah.
you going to do anything in this case, like using TEEs as well? Because I'm just curious, like what else are you going to want to use these things for? Because it could
Yeah.
run anything. I'm just curious what you are thinking
Yeah.
about running.
Yeah, so Chainlink is a very important part to our system, right? Because they basically do the proof reserve for us, and the proof reserve is more to show the user that these assets that we have in our custodian bank are actually being stored. So all the assets are backed by the total supply of tokens that we have on our ERC3643 token. Um, so that's a very important part. But there's another part there that we need to handle, and that's encrypted Oracle data. So because all of this data is encrypted that we are doing with the encrypted order processing, we need to make sure that all the data is first transformed into something called ciphertext. And ciphertext is more like a way to encrypt. So it's encrypted data. So you bring encrypted data on the smart contract, and Oracle needs a way to actually deterministically verify that this is the correct data that it needs to process to bring to the smart contract. So
Nice.
before that, it already needs to have that processed, and once that's brought onto the smart contract, then we can compute over it. So there's a very simple explanation of that. Like this happens the same with FHE and the TE solution that Inco has. So what Inco does is they build a confidential smart contract solution so you can do encrypted computations over your data.
Wow. So
Um,
you get to do encrypted FHE on the data that they.
and this is TEs right now, but FHE is also possible. So Zama has the same kind of way of doing this. So the technology is different, but the way of implementing this for the developer, so the use case for the developer is the exact same.
It's the
So
extension of privacy.
yeah, it's the extension of privacy. For example, Inco is partnering with the Circle to bring confidential ERC20s available to anyone.
So does that
So you
mean
can,
I have a quick question about the
yeah,
processing of that system, right? Is that like
yeah,
FHE? I'm planning on having a talk with Phoenix about this too, about what's going on in the world of privacy,
yeah,
because you're right, like the TEE can basically run any program like an FHE. It can even run zero knowledge proofs, and that's what I've
yeah,
seen a huge trend of what's going on is that people are sort of combining the virtual machine aspect with the actual TEE itself. So, like what's your take on this is, you're using these APIs or are they they're already routers? I guess like this is the difference, right? Is that are they deploying the contract uh for you, or like are you deploying the contract, and how does that
Yeah.
system work exactly? So you're trusting uh is it a node of Inco? Like how where do they actually process the
Well, okay, so there are two parts there. So there is a ERC20 part, right? That
mhm.
needs to be completely audited. So you cannot really build your own confidential ERC20 because that will mean there could be vulnerabilities, right? So all these function selectors need to be completely audited and correct. So in terms of that, Inco is providing that for the user. Same with the ERC3643, which I will be working on as well. Not necessarily with Inco, but I'm working on different solutions for like our on-chain identity thing, for maybe credit scores and things like that. But the bottom line is that the core parts that all DeFi is going to be interacting with is audited, so people can use that. It's the same thing as like using the ERC20, right? So you use the same interface to connect to any dApp that uses like a DeFi solution. So it's the same thing, but yeah,
Okay, so
yeah.
let me understand the motivation a little bit, I guess, behind this. The developer tooling that you're using to create the actual program, step by step. I guess like how the Spout is using the TEE to verify it identity, minting the permission token after the identity is verified with the token address on the contract, and you're using the contract to verify the private information through Inco, uh, right? And then that actually guarantees you some kind of return transfer, but it's an invisible transfer of some sort of verifiable computation. And then you're something somewhere has to be storing this. So you obviously have a database. What database are you running, bro? What is it? Yeah, what is it?
So it's right now just a SQL database
Okay.
that we are running.
So then you're painstakingly building this very complicated bond structure and how to lay this weight out.
Well,
So yeah.
most of the so what we do with the backend, so we integrate with a broker dealer, right? And that
Oh,
those are
nice.
like this broker dealer is responsible for actually buying the assets, because you need
Mm,
that license to actually do that, right? You cannot necessarily like out of nowhere connect to a clearinghouse and send orders. You cannot do that. You need a license for that. So
okay.
maybe
Hmm.
we eventually would think you want to have your own broker license, but or broker dealer license, but that's very complicated, and there's like a big legal process for that. I think
Mm.
Denari is now the first one that has like a broker dealer license on the blockchain
Wow.
ecosystem. So congrats to
That's
them.
yeah, congrats to you guys. I mean, like you guys are in an ecosystem right now delivering the first of a kind, I think, in the RWA space. And so
With
realistically,
confidentially, yes.
yeah, the
Yeah.
confidential systems that you could deploy easily and then be able to run and manage. I guess you guys have like your own sort of process on how to do this. So how does the ERC 3643 versus is there an ERC 725 I found there as well? That's for
Yeah.
the identity, right? Got you.
Yeah.
So would you say you enable selective disclosure then to the client through this?
Not through the token standard. So the
Okay.
selective disclosure is only done by through Inco. So it can also be done through different TE solutions, right? So if you want to do this at Fala, you could build this as well, probably, but you need to like build that infrastructure out yourself. So what Inco does, they are using TEs, but they are actually, yeah. So selective disclosure,
Yeah, there are
it's
pre-built
great.
images on Inco. So what
Yeah,
I've seen that Inco provides is like it's a co-process. Do they open
yeah.
source what they're processing or what that code is?
Right now, I don't think it's open source because they're still on testnet. But
Right.
yeah, I think I don't know. I can't like really say that, of course. But I think it would be good to open source
Depending on
that so
whatever they
anyone
end
can
up doing,
verify that.
whether they open source or don't. What I'm wondering is like, if
Yeah,
does anyone have the ability of okay, so this would be the difference between Inco and DStack actually, because DStack deploys your own image, except that you have to run the host. In this case, they're running the hosted programs for you,
yeah,
then you don't have to build the program. So inevitably
yeah,
it becomes a dev shop of doing, very specialized privacy guarantees. um
exactly.
I think in terms of DStack, you're going to have a different approach where you have to build in the actual systems that guarantee that privacy. And if you can make it work in a Docker container, just like with Inco, then you likely can actually execute this. But from what I understand, the only way that they can achieve that now is through using DStack. So otherwise, I don't see what their backend is necessarily doing. A lot of Web3 companies, they actually rely on like 60% of them roughly rely on for their TEE processing on the D stack. And so this is just a way of confidentially creating a virtual machine that allows you to use the key store manager, or the system that actually generates the private key. Effectively, it's the signature. They create these signatures called quotes, and they're called RTMRs. They are registries. And so these registries are available through very, very specific enclaves. So there's like SGX, and then there's TDX. And so a lot of the AI models that are running now are on Intel TDX and also AMD. And then there's like various other types of TEEs. So does Inco, do they tell you what kind of processor they're running, or they're not disclosing what the GPU is?
So I did read their white paper a few months before. I'm not completely sure, but I can get back to you later on this.
I'm
I
super
don't know.
curious about what
Yeah,
other people are doing in the space. Maybe I can invite them on to sort of discuss
but
what it is that they're
yeah,
doing. But it's like, my
but
question is,
yeah,
what do you selectively disclose is the ultimate question. Like, you
yeah.
know,
So I also wanted to say, because you correctly brought up Fallout, like how you guys are closing gaps in certain other like ecosystem problems. I think Fallout in itself is like a different solution, as in like this is more like a ready to use smart contract that's encrypted. So it's really like specialized, or a very specific solution to some developers. That Fallout has like a very generalized, general purpose. TE, right? That you
I
can
I
use
would
for a lot of
say,
things.
basically, as long as it runs in Docker, you can deploy any program, like zero
Exactly. Yeah.
knowledge proofs. You can deploy you can encrypt the memory on the CPU, and you can use the GPU, and that's the benefit of using Intel TDX. That's that specific support. And
Yeah.
so when you build out programs, you get to actually utilize the environment itself to build a system that retains privacy and confidentiality effectively within a
Yeah.
private container. So you can even run zero knowledge. This is some of our tests with running like SP1, for example. Also, like even testing things out with, Aztec, so you can run like faster virtual machines for the browser for the zero knowledge proof, because then you can have a coprocessor that also retains, because zero knowledge is not actually like private. It has to reveal itself somewhere.
Yeah.
Doing it in the browser just is very expensive. So people offload it to coprocessors like Fala to basically do trustless compute, because then it's the decentralized KMS. So all of the memory is encrypted. So we don't necessarily like look at the D stack as a way of saying, oh, like, trust me, bro, this is my machine. It's like, no, well, whatever this machine is running, I don't know what's necessarily going on inside of it. Hence, the black
Yeah.
box. I don't know
Yeah.
what's going on, but I do know what's deployed to it. And then that's like, we get to change the definition a little bit of what it is
Yeah.
a smart contract is and isn't. Because if the contract is an immutable hash of itself, like the code, then you can still say, right, that the code and the hash are the same. Therefore, the immutable contract, which is also the code running in a TEE container, which could also be decentralized. That's also the point of the Fala network, is that it's decentralized, the actual co-processing. And so there are weights and counters to that. And so it serves for a very specific niche, I think, in confidential computing, especially for trustless guarantees. And so that would be like the overall difference, is that it's an infrastructure layer for the co-processing. And so if you can build a program that's in confidential memory, well then great. Then at that point you're effectively designing programs that execute in these sort of silos. That's how I at least interpret it. And when we're trying to align I'm trying to
Yeah.
figure out all the different alignments that I have with the people who I bring onto the show, because I would say the FHE, some people sort of say, oh, like you can't do it, you can't do TEE if you're doing FHE. And I'm like, no, you could do it inside of a TEE and then run inference on FHE, which is a really fascinating use case. And people will dominate, I think, those very specific niches. And you seem like you're coming at the corporate bond side of it with the yield as well as the private transfers. So I want to go into more insightful questions, because we opened up with about you being a privacy guy, you knowing about the whole
Yeah.
privacy
Yeah.
technology. So it's like, please rope us back, because we're like all over the place. We're in TEE
Yeah.
land, we're in corporate bond land, but like realistically, you personally, I see you as a person who has the potential of building something great here. So now that yeah, Fallet obviously supports confidential processing of containerized applications like VMs. Now like if I can't get it through Inco, I can get it through Well, now your tool set expands. You, my friend, are a hackathon, or you know, you obviously build and use the tools that are in the open to your advantage. So now that this
Yeah.
is all coming clear to you, what does this all mean? What is the privacy you're trying to achieve here? Is like, what would you like to see, I guess, that's not happening in the
Yeah.
decentralized world of things?
Yeah, so right now all the data is public, right? So that's very obvious, and which is why we need confidentiality. So there's a big difference in saying privacy and confidentiality. So privacy means like, okay, I'm private to like everyone, and all, including or excluding myself, right? Because I know what's written there. But confidentiality is more like, okay, I want to be private to like most people that not necessarily have to know anything about this transaction that I just done with someone, but I still want to have like a level of trust to third parties like the government or any other association that want to investigate money laundering or anything. So this is also how the ERC-3643 is actually very interesting with this model, is because you have forced transfers. So there are clawback processes in America, for example, or other parts of the world as well, where we have people that use or done some transactions that needs to be invalidated because they were fraudulent. So we have force backs there. And then we need to have like an encrypted flow there, because you don't want to necessarily disclose or have all this information public. It could be competitors. It could be anyone that you don't just want to like see your transactions, which to any banking system that we know off chain is very is just like a very normal thing, right? Because if I send you money, the banks know, of course, that this transaction happened, and they can see all of the metadata there from that transaction or databases.
Nice.
But your neighbor doesn't know that, right? He can't like look that up. That maybe if he works at that bank, yes, it could be, but not necessarily in the whole network. And this is also why blockchain is very good in transparency, and it's still very good in transparency when we have confidentiality, because all the state is still deterministic. You're not changing anything about the protocol itself. So the EVM doesn't need to be changed to implement all of this.
Right.
This is just we are encrypting this state.
The identity of the state of the identity, the state of the transfer. No.
Well, no. So the state of so the identity, no, but like the transfer. So we still have this state that the EVM can verify if this is correct, but we just have this encrypted. So we can still like use all of the protocol guarantees. We don't have to change anything, and we can have a much better way of moving value. So
yes. Okay. So you want to be able to transfer value, but
yeah,
in a sense, how would you sort of simplify this, I guess, for the everyday person? Like the goal ultimately is that there is a problem with, like, for example, MoneyGram. So if somebody is trying to send, I don't know, like yield to anybody, it's not necessarily that common. So when you're using this system, you're basically able to now transfer something that was once extremely complex to transfer. Now you can actually transfer these very complex and also very deeply compliant bonds using
Yeah.
these very trustless and also verification guarantees through like TEE, co-processing, all of this kind of stuff, right? Like you have all these
Yeah.
other issuers that are also helping in the verification of it, like Inco, and then you basically end up building out programs that I think are extremely robust, and they can get there. So I guess, how far are you guys? Like what comes next? What's, I guess, like the next year looking like for you in your roadmap? Do you have, you know, any kind of uh pivotal sort of like new ecosystem shifts that you're going after in the RWA space? Is there anything specifically in the RWA space that's like cool or niche? Like, I just don't understand it well enough to speak about
Yeah.
it. So what's going on in that space of ideas?
Yeah, so DeFi integrations are going to be on our roadmap for now. So we want to integrate with all the major lending protocols. Right now, we're starting doing that on Ferras, but the lending protocol integration is most important because this asset is perfect for collateral. Uh, so that's on the roadmap. The confidentiality, it cannot be issued right now because it's not a mainnet now. So that's going to be testnet until the actual technology from Inco releases, which it has no public release date yet, but that could be anytime soon, or we have no like clear
Yeah.
goal on that. But except for the confidentiality, we are focusing so on the DeFi integrations.
I'm
That will
curious
be
about the DeFi integrations, actually, because those are some
yeah.
of the near term things. So you have like things like Chainlink, you have things like, you could obviously use DStack and whatever. You can use, I don't know, like any blockchain that you're looking for. So you're going to deploy this first to Ethereum, or what's the chain
Yeah.
of choice? Okay.
Yeah, so normally you can use Chainlink oracles also for
Mm,
cross-chain data sharing, right? But right now we already have that only for the proof of reserve, so we can do that cross-chain. We are also working with we are going to look into the automated compliance engine from
yeah.
Chainlink that was built with the ERC 3643. So that way you can automate the compliance flow for cross-chain products, which is
Wow.
very promising.
Wow.
Um,
Yeah,
but
that is like a totally different field outside of my scope. Now, like the actual misconception that I have about it is that like you guys are gonna, it's like you have a hard time being able to display all of this data, but then using Chainlink in that sequence allows you to now have verifiable assets that are off chain, and you can
yeah.
still co-process with them on chain using ERC3643, and you can manage the identity with 725.
Yeah.
So I'm piecing all of this together in my head. I have no idea how you pieced all of this together in your head, but Paul, walk us through one last thing for us. What is your 2030 like landscape look like for AI? Have you thought
AI.
about it? What's sort of like, I guess, your take on this?
Yeah. So in my opinion, like AI right now already did a tremendous job on changing the engineering ecosystem. So
Mm-hmm.
I don't really believe in this whole notion like engineers are going to be replaced or any of these like black swan scenarios. But I do believe that AI is going to they are going to play like a extremely big role in how we do asset management, for example. So data can be processed and pieced together much faster. So I think markets are going to be much more efficient due to AI innovation, which means that if we can have much faster compute, much faster ways of like piecing data together and giving like a much more accurate view on like a certain stock price, calculate
Absolutely.
that price efficiency much better. That could tremendously change this whole ecosystem.
I want to know like how I can just do everything where I can manage my yield with AI. That would be interesting. And then I think you guys would be one of the first that can train a model based on your own architecture, even too. So you would fall into your own niche. And believe it or not, you can run the AI completely confidentially, like DeepSeek, Llama. Like we've been able to run all these different models, like where we don't even know what it's thinking or what it's inferring, but it can be trained. Like Eliza was basically just put on full blast, and it was sort of like quote unquote the unruggable agent. But I guess like, do you see like a problem in like the way that like traditional regulations for these types of yields, are they like commonly more risky? Because, a person like me, the only reason why I don't touch a lot of these types of assets, like as a retail user, as like an everyday person, is because I don't necessarily know what it's doing. And also like a lot of the complications that go into me actually investing into these assets, not like it's your platform is a bad idea. I'm not saying this. I'm just saying like, it's hard for the everyday investor to invest into just like stocks and bonds, but then let alone yield. I think like your UX UI sort of approach that I've seen on Spout is actually very clean, and you guys have a very specific approach that you think just needs to be boom, 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 very just do this one thing. And I think that's the huge benefit of DeFi in general is that like it demystifies the complications, and it basically prints it as a, hey, this is the amount that you want. You can transfer it. There's no harm, no foul. And everything is handled in the back end by the confidential processor so that both parties are happy with the transfer. Is that correct? Like, the transferring of the asset, I think, is a very important aspect of what you're saying. You're using confidential virtual machines, but then the decentralized component remains completely hidden because the confidentiality is actually aggregated into the coprocessing of TEEs, which is a very secure way of doing it because it's not stored on the actual TEE. It's just processed inside of the TEE. Is that like where I'm understanding that it's a really large architecture. So, it's like I'm trying to piece it all together in my head right now. So, you guys have thought about a lot of things. I want to ask you more questions. Are you open to a few more insightful questions, or if you have to run?
Of course. No. I'm
These are interesting, right? I think these are just like whatever you want to say about these. I'm trying to understand the world through your lens too. I want to understand, you're on this mission, you're on this drive, you've done all these things. Where do you go next? What's the next thing that you're doing now?
So for Spout or in general?
Yeah, like, well, your plans for Spout is one key thing, but in general, what I guess keeps you up at night? What is the problem that you're solving right now?
I think DeFi right now, it's not only fragmented, but it also loses on a lot of potential through these more like efficient financial instruments that we can implement, such as efficient collateral through corporate bonds. So right now, I know there are like a very interesting arguments you can make for tokenized assets like stocks or bonds or anything, opposed to how we do it off chain. So if you think about it, you can actually right now swap an asset directly through the on-chain liquidity for these different assets instead of like you have your broker off-chain, you trade your stock, and then having to use that money to buy another stock or anything. So that is like a very big advantage actually of on-chain finance. So normally you have all these different brokers that are completely siloed. So you have to switch from one broker to another, and that's not easy. Like that whole process for a user to switch brokers is like an incredibly tedious task, and it's not user friendly at all. So that's one thing. And we also have another thing. You can actually borrow against these assets. So borrowing against ETFs and things like that is actually something only billionaires could do. Because if you're like a Jeff Bezos or something, you can easily borrow against your Amazon stocks, right? Because the bank already has this guarantee, like, oh, you're the founder of this company. you are obviously going to pay back this whole loan on your $100 million
Whoa.
house or something.
That's pretty
Now, an average
epic.
consumer can
Now
do that.
everyone can do it. Yeah, yeah, yeah.
Yeah,
And so you want to make it easy for people to borrow in large sums then? So there needs to be sort of sums of RWAs that are sort of able to fractionalize themselves, right? Or
yeah,
like I guess from the Spout angle, people come to Spout with a large sum or a liquidity provision, and then they want to basically hold on to that real world asset, but then I guess
yeah,
they are looking for other people to what match the investment so that they always like what does the liquidity provider get out of reserving the asset, giving over the liquidity sums to say like a decentralized token issuer? Like you have just typical treasury bonds versus like these atypical treasury bonds in this case. Can you
yeah,
explain to me that difference? Because I want to understand the strategy here as far as the maturity of the asset.
yeah.
Why have other people sort of, you know, use this rather than in traditional settings? Because it seems like this is more scalable for a lot of reasons that I'm not piecing together right now. Does that
Yeah,
question
so
make sense? Yeah.
yeah, you mean like the difference between you mean treasury bills and corporate bonds, or you
Oh, no,
mean
no, sorry.
bonds
Like
in particular?
your platform gives you the
Yeah,
ability of being able to aggregate large sums of people to commit their
yeah.
liquidity, but it's their liquidity that matures as those assets over time. If and
Oh yeah,
only
yeah.
if Spout has a one-to-one match with like say like what do they
Yeah,
commit,
so
stable coins only or Bitcoin or no Bitcoin?
there's already a distinction here. So we have ETFs, right? So ETFs are managed by the primary issuer itself. So that's BlackRock right now. LQD is managed by BlackRock. So there is no maturity that we need to take advantage of, or we need to keep in mind with the user having these tokens, and we need to buy these assets again for like a rollover or something.
Mm-hmm.
So if we have T-bills, for example, we should do that, right? So we have all these different maturity dates that we aggregating in one pool, and those all have like different maturity dates, different yield rates, depending on if they are short-term, longer-term maturity dates, or if you only do short-term maturity dates. They also tend to differ because the secondary market gives a total different price to each of these bonds. So
Mm.
then we have something called the NAV, right? Net asset value. So the net asset value is actually then like the net worth of that asset minus the liabilities, which gives you an accurate price for like the average price you could get per asset that you have in your fund. So this is also a very like different legal strategy that there are a lot of competitors are going to go for, which is a fund.
Mm.
So if you are if you have to manage all these assets, then you are a fund
Mm.
by default. So with T-bills, this is very obvious because you need to buy all these T-bills yourself. And with corporate bonds, you don't have to because you can do that as well, of course. But with the ETFs, you don't have to because there is already a primary issuer.
Yeah.
Otherwise,
So are you
you
guys
are
coming out with like well you're the supplier of this, right? So you want to be able to
yeah
provide the supply itself. Okay, that makes sense. So you want to be able to
supplying
provide
infrastructure, right?
uh-huh.
Because you have to supply, but the users also need to trust a centralized issuer that
Uh-huh.
actually these assets are stored. So that's also one very important part of this whole formula. Like you need to have a trusted collateral issuer
Uh-huh.
that people need to trust in terms of redemptions. Because if you are going to look at a lending protocol integration, for example, the lender and the borrower. So for the lender, they are not necessarily KYC'd on our system. Only the
Uh,
borrower is.
right.
But how can you make
Oh.
it so? How can you make it so that if you default as a borrower, that you can still deliver those tokens to the lender because they're not KYC verified? And of course, according to the rules of
Ah.
the ERC 3643, they cannot receive the tokens. So they cannot receive the tokens. They cannot redeem through us. So what we then do, we can sell those assets further from the borrower when he defaults, and then bring on that USDC for that lender to claim it through us, or it can send it, like whatever is more secure, right? So we are still figuring it out what would be more secure there, but that's a whole case you're working with.
Yeah, yeah, yeah. So those settlements can happen in the back end on the off-chain processing as well.
They
Like you
are,
can make that
yeah,
confidential as well. That's all. Wow. Okay, and now I'm starting to understand the trusted manager. But in this case, do you think in this development fashion, then you're becoming your own sort of like decentralized, trusted issuer effectively. Like you can issue your own, like it's like through this
Well,
platform, people have a much easier way of being able to issue liquidity without any kind of like drawback. They at least get the guarantees up front. Even for like, if you could do this for yield, why couldn't you do this for just like any asset, right?
you could, right? And it's I think it's not accurate to say
Mm,
decentralized issuer, because we are centralized. I think if you look at, for example, Circle, they are also centralized, right? It's just a central entity that enforces trust in the whole ecosystem. And then we have Tether, of course, that have less trust. There's less trusted by the ecosystem, because they
mm.
are not able to give that same level of like backed issuance trust, like if there's really a one-to-one issuance or
That makes
anything
a
like
lot
that,
of
right?
sense. That makes a lot of sense, especially
Yeah,
for operations like yours right now. And then, yeah, I 100% agree. And the choices and the decisions behind that, I can see how TEE confidential computing really sort of advances your guys' roadmap for a lot of those sort of security guarantees, or especially
yeah,
around the compliance for how you guys, even in central controls, you can still like cooperate it with these other systems and still get feedback. But then that feedback
yeah,
can also be very confidential, and you can prove to your clients that you don't get any information that you're not supposed to see. You just do a zero trust arrangement that's a program, and then you just click
yeah,
the buttons and then you ask them for the information. I think that could even
yeah,
be a much more smooth process, because you're like, I never see your account number unless you reveal it to one of my employees at my company.
yeah,
Like,
yeah,
and they're
exactly.
also
Yeah,
liable for not sharing the information. So yeah, like definitely when it comes to security operations and protocols for finance, you guys are totally, I think, redefining the direction of where an RWA needs to go. You're doing it through just using technologies that kind of make sure that the process and the workflow is much easier. You also sound like you have a roadmap that actually allows you to manage this in a sort of a trusted
yeah,
fashion, but then that trusted fashion can also be extremely efficient. I don't know where that goes, and that's probably too far ahead into the future. But like I think that's why I brought up AI. I want to understand how maybe safe AGI can actually help automate some of this stuff for even your team and your company through like already
yeah,
pre-architected inference models. Like you don't necessarily need to go through anybody, but like there's already a pre-deployed confidential image that runs that inference every single time. And I think some of those systems are going to become a little bit more popular as sort of time moves on. Is that people are going to need some guarantees in their process, because it's just too hard to build secure systems. I've noticed.
yeah.
Any last thoughts, Paul, on what's your takeaway from, I guess, the project, what you learned from the entire experience of like, you're here today, you look back at this and where you started a couple of months ago, and now it blown up with the success of winning the Chainlink hackathon, so congratulations about that
Thank
recently.
you. Yeah,
2020, yeah, like you won for basically the same process. So but then obviously you employed the Oracle systems inside of it too. So you guys figured that integration out, which is fantastic. So the last thoughts on like what your takeaways were for anything that you recommend to developers like out there who want to build, I guess.
yeah. So my main takeaway would be to discover a lot of like different parts of the ecosystem and really define your passion. So when I started out doing hackathons, I was very privacy focused, but I also explored a lot of different areas, which I would say like that makes a lot of sense for people coming into this space. Who wants to start a business, for example. So I was always very entrepreneurial focused, and I always want to start doing something innovative. And there are also people that want to like get into the Web3 space to get a job, for example, and then your route would be maybe different, right? So still hackathons would be extremely recommended for me, because they taught me so much about how different protocols work, and also how to work with them, and gives you so much more qualified opinion on how the whole ecosystem works. So I would say that's one thing that I would really want to recommend: do hackathons as many as possible, go to events as well, because like
Do
literally
as many
I started
hackathons as you can. Yeah.
I started getting into blockchain, which was last year November. So not so 1.5 years ago. I mean,
Uh-huh.
and I was reading the Bitcoin white paper back then. I
Wow.
already like I studied business. I didn't do computer science, but I
Nice.
was already a programmer
Self-taught.
on
Yeah.
the side.
Great.
I
Okay.
was self-taught, like a lot of people, right? So, which is great. So there are a lot of self-taughts here, and in July, like last year, I was deciding to really test my knowledge. Like, did all the research papers that are already read from different protocols.
Mm-hmm.
Do I have the knowledge to actually build something with it? So yes,
Mm-hmm.
I participated there with the Starknet hackathon, which won me the grand prize with two amazing guys, Philip and Mier. Um, I can't shout out them
And you
for
guys
the
just
Twitter right
became
now, but
best friends forever since then. So,
yes,
yeah.
exactly.
And so
So
you
we
meet
had a
some of the best
cool lore.
friends in your life. You know, you go to hackathons, you end up doing something that's like totally out of this world, and then you end up, you know, really vibing afterwards and building some other cool
Yeah,
stuff. Yeah. No, I totally get that.
I
So you
I
made a lot of
went all out
friendships.
actually.
Yeah.
Yeah, I went all out. I went to a lot of places around the world. So I even met you in San Francisco,
That's right.
which was in
Yeah.
October.
Yeah, that was a
And
good meeting. I remember that. That was when we were first describing some of the password stuff that we were doing. So yeah, there was a
exactly.
lot of that. Yeah, okay.
Yeah,
So your past trails all the way down to the very edges, and I remember when I first met you and we were talking about privacy, we were doing so many things. So I'm happy you were like the first guest that I can bring onto this because
yeah,
I kind of want to show everybody that this is a place for you to really discuss your ideas, your actual thinking about the technology, and you know, hopefully we can go as deep as, you know, as you'd like next time. So I'm looking forward to what Spout does next because you, I know, think about all of the different technicalities in the architecture, and so it's really interesting to hear your perspective on like how you're sort of thinking about RWAs. You know, what is the
yeah,
space of ideas in the financial systems, and then we also broke down a lot of the, you know, the co-processors today. So why you're using them, what are some of the security guarantees, and I think like that was exactly what I was expecting. And you know, you showed up. Okay, so thank you so much, Paul, for your
yeah.
time and all of your work, and it's really appreciated, and thank you for open sourcing some of the things that you've done in the past. So I look forward to like sort of
Yes.
your work in you're trailblazing the RWA right now. So
Mhm.
yeah, and see how we can help on our end, basically see how we can actually get you across that sort of safe AGI roadmap line that we're going for, which is, you know, how do we actually make these systems so clean, so easy. That's my goal, is to make sure that it's easy and you know, not so hard and difficult. I think so much DeFi is very confusing. So
Yeah.
yeah, I looked at your guys' page and it's not so confusing anymore, especially yield. So good job. All right, Paul. Well, all the best. Thank you so much.
Yes. Thank you, Dylan.
That was Paul Mierlo of Spout Finance. Thank you, Paul. This episode is sponsored by Fala Network. To learn more, visit fala.network and explore DStack, a generalized T framework for zero trust by design. To support the show and the confidential compute community, follow at Fala Network and at Run with the Box on X. Share your takeaways with hashtag Blackbox and star the DStack/TEE repository on GitHub. I'm Dylan Kowalik. Thanks for listening. See you next week.